Hello, welcome to my channel. The episode is for papers, past question papers. So right now I have this Additional Mathematics paper 1. Okay, and it is May, June 2025. So we have already solved, I believe, 10 questions. So we will be doing question number 11 and 12 today. The previous question the other question you can check in my previous videos. Okay, so here we go. We have this situation that the particle moves in one dimension. For example, this is the point O, and the particle moves around this direction, right? So at any time, its position is given by these two expressions. Okay, so first 3 seconds, the position is governed by this equation. And after 3 seconds, it is by this equation. Okay, so uh, it is given that in all this interval, no, after 3 seconds, the velocity is positive and acceleration is negative. Okay, we will talk about what does it mean. Part A says the maximum velocity is 2, okay, on the axis below sketch velocity time graph. Okay, so how do we sketch velocity time graph? Remember the derivative of this displacement, okay, that will give us the velocity. Okay, so if I try to uh, make the equation for velocity, where should I write it? Okay, let me write it here. So velocity is going to be, so if I differentiate this first expression, it is going to be 1 plus 12t minus 3t squared. So this is the velocity when t is between 0 and 3 seconds. And later on, it is 12 minus 2 by 3 t. This is when time is more than 3 seconds and less than some k seconds. Okay, so we have to sketch these equations over here on this axis. This is the velocity and this is time. So let me mark some points here. Let's 1 and 2 and 3, for example. Okay, so you can see that in first 3 seconds, this expression is an equation of a parabola. And this is negative 3t squared, means it is opening downward, right? And the other information, we know that the maximum velocity is equal to 2. So from these information, and let me make a quick table, a short quick table, and t, and this is velocity. You can see that when velocity is 0, 0, 0, it is 1 only. When time is 1 second, so it is going to be 1 plus 12 minus 3. So this is 10. Okay, velocity is 10 meters per second. When time is 2 seconds, so it is going to be 1 plus 24 minus 12. So this is 13. Okay, and this is the maximum velocity we know given over here. Okay, and at 3 seconds, again, it is 1 plus 36 minus 27. So 36 was on 37 minus 10 again, right? So this is easy. It's difficult to make a scale over here, but let's roughly make it. This is 13, and this is, let's say, 10. Okay, and somewhere here is 1. So when time is 0, it is 1. When time is 1, it is 10. When time is 2, it is 13. I think 13 should not go so well. Let me make it here. And 3 is again 10. So you can imagine it's like a parabola which goes something like this. Okay. Let me correct this 13. Make it here. Okay. I hope it's clear that I sketched this first equation, which is from 0 to 3 seconds, like this. Now, the second part of this equation, this is a straight line. Okay. So you can see, let me make only 2 points. When t is 3 seconds, it is 12 minus 2, so this is 10. Okay, and this confirmed with this one. Okay, and when time is, let us see, if I make it 6 seconds, okay, so 6, 3 to the 7, this is 8, okay, and okay, so this is 3, so 6 is somewhere here, right? This is 6, so it goes straight like this. So this point is 8. Okay, I'm not able to make things according to the scale, but you can have some idea. Okay, so this is the extra. Okay, and we can extend the same line because the same line go up to k. Okay, whatever the value of k, it will give you the value of the speed like this. Okay, so on this accelerometer scale, just velocity time. Okay, so this is part A of the problem. Okay, I hope this is clear. Now let's move on to part B. The total distance traveled by but the point of particle is 57 meter. Given that 20 is 3, the distance and the displacement uh, of the equal of the parent are equal. Find the value of k. Okay, let me make one thing clear. What's the difference between distance and displacement? Okay, if I have this time velocity curve, and let's say it has something positive and something negative. Okay, so what does it mean? The speed was increasing and it was decreasing, but it's still positive, right? So the object is moving, it could keep moving in the opposite direction. Okay, it slows down, it speeds up and slows down as it is over here. And at this point in time, it becomes zero, speed becomes zero, so it stops, right? After this, it goes in the speed becomes negative, so it starts turning in the opposite direction, right? And it come to stop again here. Okay, so this is over here. So if I talk about displacement, of course the displacement is zero, right? So from this graph, if I add these two values, this is positive area, this total area is something positive, and this total area is something negative, right? So if I add them together, it will give me the displacement. But if I take this and this, it will give me the total distance. Because when you travel from here and come back, it has some distance. So whenever you have speed, sorry, velocity times curve, right? If you add total area, assuming this area has to be positive, it will give you the distance. But if you subtract this positive area from the negative, it will give you this displacement. Now, in our case, you see everything is positive. Of course, if k is too large, this will become negative as well, right? But we are told that uh, yes, it is given over here. The distance and displacement of p are equal. Okay, equal means that the all positive. Okay, anyway. Okay, so in this problem, the total distance travel is 57 meters. How can I find the total distance? Okay, one idea is to integrate this whole thing, right? Integrate it up till time k. Okay, but the second thing is that we are given that the total distance is 57 meter. Okay, okay. So when t is equal to 3, okay, when t is equal to 3, what is the distance? Okay, you can calculate from this expression. Okay, so I'm trying to find the distance or displacement at time t, at time 3, okay, and that is equal to 3 plus before, right? Uh, okay, and minus and 27. So this is going to be 27 plus this is 30. Okay, so at up till time 3 seconds, it has traveled 30 meters. So it has to travel 27 more meters. So that means this equation will work. Okay. So I'm trying to calculate the distance or displacement. They are both same, right? In this case, how much it is? I will use the second equation directly. Okay. So the second equation is, all right, difficult for me to write it here. It is 12t minus 1/3 t square minus 3. Okay, so let me do this again. Okay, so this is part B I'm trying to solve here. Okay, so we have known that the distance or displacement is equal to 12t minus 1/3 t square cube square and minus 3, right? Okay, so at k second, this distance is going to be 12k minus 1/3 k square minus 3. Am I right? And this distance is given as 57. Okay, and we have to solve this equation and find the value of k. Easy. So it will become 60 here. So I have minus 1/3 k, not I need to write 1/3 k square and plus 12k equal to 60. And if I multiply by 3 everywhere, it is minus k square plus 36k equal to 180. Am I right? Okay, so this is basically k square minus 36k plus 180 equal to 0. Okay, so we need to solve this equation. I need to factorize it. So 180 factor can be 30 and 6. Yes. Okay, and they both has to be negative. It will give me this. And yeah. Okay, good. So it is going to be k minus 30 into k minus 6 equal to 0. Am I right or no? You see, let's say if I multiply these two things, then minus 30 minus times minus 6 is going to be minus plus and 180. And if I add them together, this is going to be minus 30 and minus 6, minus 30. So this is correct. So from here, I learned that k is equal to 30 or 6, right? Okay. Now, what is the correct k here? You see, 30, let's check what happened in case 30. If I substitute k equal to 30 here, right, in the speed expression, yes, in this expression, then the velocity at 30 seconds, it is going to be 12 minus and 2 by 3 times 30. So this will be 10 times 2 minus 20, so it will give you minus 8, right? So the velocity becomes negative, but we know that velocity is not negative anyway. You see, it is given in here, I believe. No, it's written over here. Yes, the velocity of p is positive in this interval. Okay, so that's why we will not take 30, we will take 6. Well, you can check that if k is 6, the velocity is positive. So this is our answer. Okay, I hope everything is clear over here. Okay, now let's move on to number 12 here. This is, I believe, more simple. Okay, we are given 4 times x over 2 plus ax plus 7. Okay, so we have to find the equation of the normal to this curve at x equal to 2. Okay, if x is 2, what's the value of y? From here you can see it is 4 and 2 times minus 2 and plus a and x is 2 again plus 7. Am I right? So 2 times minus 2, 1 over 2 squared, so this is 4. So it will become 1, 4 over 4 is 1. It will give you 2a plus a. Okay, so it means I have to find the equation of a number a, 2 and 2a plus a. This is the point on the curve where I need to find the equation of the normal. Okay, now the second part, what is the slope of carbon deflection? Dy by d is going to be x power minus 3 plus a. Am I right? I can write minus 3 over x cubed. And let me find no. when x is 2. Okay, I know that. Okay, so when x is 2 over 2 power 3, which is 8 again, a minus. Okay, so this is the slope of the tangent line, right? So what's the slope of the normal line? Slope of normal line, it is going to be the percentage to the tangent. Negative reciprocal of this, it's between 1 and 1 minus. Okay, so the normal line, it is passing through this point, and it has a slope of 1 over 1 minus. Okay, so these two pieces of information, they will help us finding the equation of the normal line. Okay, remember, if I have to find the equation of a normal line, and I know a point from on the line and its slope, the equation I use is y minus y1 equals m times x minus x1. Remember? So y minus y1 is 2a plus 8, correct? M, the slope is 1 over 1 minus 8 into x minus x1 is 2. Okay, so this is the equation of my normal to this curve. And so that means where times y minus 1 minus 2 times 2a plus 8 and equals x minus 2. Right? Okay, let us rearrange. I will say x. Okay, x. And if I take it on the other side, it will be minus 1 minus a times y. Okay, and equals, I will bring 2 on the other side, 2 minus 1 minus a into 2a plus 8. Okay, x and this goes to the other side become negative, and this becomes positive. Yes, okay. So I wrote this equation in this form. Remember, this form, x plus 4y equals b. Okay, so I'm trying to write it in this form. Okay, I don't know modification. Can I say plus here and a minus 1 times y equals 2, and so plus here and a minus 1 times 2a plus 8. Okay, we know that the equation is x plus 4y equals b. Am I right? This is the yeah, x plus 4y equals b. Okay, so it means this part a minus 1 is equal to 4. So a minus 1 is equal to 4. It means a is equal to 5. Okay, so if a is equal to 5, then right hand of the equation it will become 2 plus 5 minus 1 is 4, and 2a means 10 plus 8 is 18. Okay, so how much is this? This is 74. Okay, so my equation, it will become x plus 4y equals 74. So you can see the b is 74. Okay, this is how you will we will get the final answer. Okay, I hope you understand both question and the logic behind every step here. Okay, if you enjoy this equation, these videos, if you find them beneficial, then please subscribe my channel. Thank you for watching. See you in the next video.